Welcome, friends. Have you ever wondered how things repeat in nature? Well, let's take a look at a couple different ways that can happen. Notice I have these bottles set up here, and I look for a pattern. That's what we do often in sciences. Can we find something that repeats over some, for example, quantity? We'll take a look here. You see, this is 5 inches, 6.5, 5 inches, 3.5, 5 inches. So as you can observe, the water patterns clearly do repeat here. Is there an amount of space required for the pattern to repeat? There certainly is. Take a look. Along the measuring tape, it goes from 0 inches to 16 inches. The distance required over space for a pattern to repeat is called, for example, the spatial period. And that's it. So like 16 inches as an example. Really easy. That's an example. Take a look. These periods that happen in space can obviously be bigger. Take a look. This is what I mean. You see I'm kind of redistributing the bottles. So now it takes, I'm going to move the camera a tiny amount. You look over there, you see on the right side it takes up to 20 inches of space for the pattern to repeat. So now I would say that the spatial period is 20 inches, the way you see here. That is from the first bottle, which is at 0 inches, measured all the way to the right, which is 20 inches. So it takes 20 inches of space for the water height pattern to repeat, as you see. Of course, you can compress these spatial periods. What I mean by that, let's not get fancy here. Take a look. You can just push the bottles together. And you see now, I'm going to adjust this just a tiny amount, like this. So now it takes about 13.5 inches of space for the water levels to repeat, the way you see here. And that's all it is. It's nothing beyond that. So we can have spatial periods of various values. Now, some of you may recognize this pattern, hopefully, when you look at it, right? It's 5 inches, 6.5, 5, 3.5, and 5 inches. Like if you imagine, it kind of looks, as you can see, like a sine wave. You see this? So that is something that looks like shown here. That's one kind of period, a spatial period, an amount of space required for a pattern to repeat. Let's take a look at a different kind of period. I'm going to put some of these bottles aside, and I'm going to focus on only a new kind of period. Take a look. So I've gotten only one bottle into view right here, the way you see here, and notice I have a black line marked on it. And imagine that the position of this bottle is at 0 inches. Take a look. Remember the things, if you think about them very carefully, right? They are both in space, but they are also in time. These are pretty deep concepts if you think about them, right? Because the two, like, it's very hard to separate the two. This is what I mean. Take a look. See, I put my measuring tape in that position at 0 inches. I'm going to put the bottle right here. I'm putting the bottle kind of in this position at 0 inches. So this portion of the bottle, to be very clear, is at 0 inches. So there's still a spatial place, a spatial placement that occurs. All right, but I'm going to bring it up so I can actually, work with it more easily. So I want you to just remember there's a spatial position still involved, as always there is. Let's look through this water level in this current stage. Never mind the black line for now. You see that this water level is a constant 5 inches. This is what I mean by saying that it's constant over time. It's nothing fancy. Look carefully. I'm going to grab my phone here, and I'm going to put the clock on. And you see how the time is passing in the background, but the water level is not changing? So the water level is a constant value, in this case, say at 5 inches. It's independent of the passage of time. If it were not, in other words, if it were dependent on time, then it would be changing. But here it's not changing, so it's independent of time. And that is all that means. Very simple. I'm going to do something else now. I'm going to take this, and I'm going to take the water level, and I'm going to make it depend on time. What do I mean by that? Let's see. Take a look. I'm going to use this as my kind of thing for propping up my phone so that I can keep track of the time and I don't have to hold it with my hands. Otherwise, it's almost impossible to do. Like that. So that's kind of in the background. It's basically like a coordinate system that I built myself. The fact that it's there is not important. I just need something to prop up my phone. That's all, okay? That's the only reason I have it there in the background. I'm going to switch this to this line right here. And then I'm going to raise this camera a tiny amount. I got to arrange things, so give me a second here. There, so I'm back. I'm just going to open this bottle here, take a look. And first thing, to be able to simulate a temporal period is like, I need to make the water level rise to some value like that. So that is our new equilibrium water level. It's stable at that new height, whatever it happens to be. So that 5 inches is not the old value. We don't care about that anymore. I care only about this new height. And now when you pump a bottle, look, the water level rises. You see that? And then after that, as you can see, the water level also falls. Anyway, that's a kind of like a homemade, way of simulating the rising and falling, for example, of the tides. Just squeeze the bottle and do the best you can. So look, in the background, I have a phone, and I've set it to be 20 seconds. What I will do is my best to try to simulate a 20-second cycle for the water levels as time passes. So I'm going to hit start, and look, I'm rising. See that? I'm rising, 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 and then I got to start falling. I fall through the middle value. I kind of fall down as much as I can. And then after that, I rise back up over a period of seconds, and then I'm back to about where I started right there. And that's about a 20-second cycle, just the way you see here. So that is all that is, and the amount of time required for the water level to go up from a starting position, come back through the starting position to a low level, and then back to that starting position. So that's a 20-second cycle. Take a look. I'm going to reset this a little bit. I'm going to reset my clock. I'm going to make it say only 10 seconds just to show you that temporal period. This is called a temporal period because it's something that happens over time. So temporal. I'm going to try to run this over a 10-second period. So in that case, obviously, this is half of the original period. By original, I mean the original was 20 seconds. Now I'll try to do it in only 10 seconds. Take a look. Beginning from that black line level, I'm going to hit start. I'm going to try to rise to some high value. I'm going to try to fall to some low value. And then after that, I'm going to try to rise back up to some high value. And that's about it. And that took 10 seconds. So clearly, that was half the original time. I can make the period smaller, which means the process that you're studying happens faster, like the rising and the falling of the water. It took only half the original time. And of course, as for spatial periods, if you wanted to, you could go very gently. Look, like do this over a very long period of time. I squeeze very gently, make it rise very, very gently, very, very gently, very gently, and then make it fall very gently over 1 hour. I wouldn't do it that, obviously, but you get the idea, I think, at this point. So that is it for this one. Thank you so much for watching. I hope you see by now that the concept of spatial and temporal periods is really nothing particularly sophisticated or scary, to be honest. Thank you so much for watching. Please leave a like and subscribe. And I'll see you in another Physical Math video.